4.5 distance time graphs. Now, in this section, you're going to be doing our work on Desmos and the iPads. But in case you finish the activity and you just want to double check your work, or you just want to make sure you get the worksheets done based on what we did in the activity, here are the what you should be filling into your notes. So here's distance, speed, and time. Part A, how can we tell graphically if an object has stopped? So if you're looking at a graph, how do you know an object has stopped? So if you have an object moving and x-axis is time, and you have a certain distance in kilometers, it's moving away from a starting point. So if you look at B1, the dotted line, or B2, and B2 even the solid line, B2 just goes straight up. It just goes straight up. It doesn't make any changes in the line. Straight line, meaning consistently as time moves on, the distance is moving away at a constant rate. Okay, but for the dotted line, notice how it goes up to 100 kilometers and it stays there for 1 hour. Right, it stays there for 1 hour. It stopped, and then it moves on after 2 hours. Moves on again. It moves 300 kilometers up to a distance to 300 kilometers, and after 300 kilometers, it stops for another 1 hour. So when you see this horizontal line, that's when you know that the object has stopped. It's a horizontal line. Okay. Part B, how can we tell graphically an object is traveling faster or at a faster speed than another? So if you look at, just compare what you see here with just up until 1 hour, okay? From 0 to 1 hour. The solid line until 1 hour goes up to, let's say, what is this, 20, 40, 60, just a little over 60 kilometers. But the dotted line goes up to 100 kilometers. So it has gone faster than the solid line. It's faster. Okay, so how can you tell by looking at the lines? The dotted line's faster. Well, it's a steeper line. Whenever we have a steeper line, it's much more steeper than the solid line over here. If it's a steeper line, that means it has a faster rate. It's changing faster than the other one. So it's a steeper line. And we say that it has traveled more distance and in less time. So it's traveled more distance in less time. Part C, calculate the speed of each car in the given graph. Well, the speed of a car is just taking the distance and you're dividing it by the time. That's the formula that we're going to follow. So for B1, that's the dotted line. How far has it traveled? It has traveled, so just looking at the first section here, 100 kilometers in 1 hour. Its speed is 100 kilometers per hour. So it's going to be 100 kilometers divided by 1 hour. So therefore, 100 kilometers per hour. Okay, look at car B2, the solid line. It has traveled, say, in 3 hours. You can take a measurement of 3 hours at 200 kilometers. It has traveled 200 kilometers in 3 hours. So 200 kilometers divided by 3 hours. The speed then therefore is 200 divided by 3 is 66.7 kilometers per hour. Okay, not as fast as the dotted line, B1, but they eventually reach the same distance at the same time simply because B1 stopped twice. So constant versus varying speed. So when you're leaving the home, if you're driving at a constant speed, you're starting at your house at 0 and you're leaving at a constant speed, your line is going to just be straight. It's going to be straight. There's no stopping. There's no increasing. It's just this constantly straight line. The rate that this line is changing is constant. Okay. If you have an increasing speed, then your graph is going to look something like this. Okay, meaning at the beginning it's slow. Like you're not changing a lot. If this axis was distance and this is time, in the beginning you're not changing your distance very much. But when you look at this section of the graph, let's say going from this point to the end point, that's a huge change in distance in such a small period of time. So that's an increasing speed, okay? And a decreasing speed, same idea, but it's a curve in this direction. So looking at such a small change from here to here, that's a small amount of time, but a huge change in distance, right? Huge change in distance. So the huge change in distance in a small amount of time, that's fast. That's very fast, right? Over here in this section of the graph, you have a small change in distance over a longer period of time. So if you're taking too long to just change your distance, so you're getting slower. So here it's faster, here it's slower. So you're decreasing your speed. Okay, if you're returning home, your graph's going to look something like this. So you're starting away from your house, and you're going back to your house. Your graph's going to go down. In terms of increasing speed, so you're going to have a graph that looks something like this. And if you're decreasing speed, something like this. So the next page below are just some practice questions for you to do for this section. And the answers to these practice questions will be posted on our Google Classroom. And that ends this video.